So 2.2 is on adding and subtracting polynomials. So remember that a polynomial is just an expression made up of algebraic terms. And an algebraic term just means it's a combination of numbers and letters being raised to a power or just a constant. The way that a term is separated is by adding or subtracting. And we can have different powers on the same variable, but then those wouldn't be like terms. So same variable, different exponents, fine. So it says variables are only raised to positive integer exponents for it to be a polynomial. So if I had something like x to the -3, that's not a positive integer, so that's not a polynomial. All right, or if you had x to the 1/3, that's not a positive integer, so that's not an exponent. I mean, not a polynomial, sorry about that. Okay, so we want to keep track of those little things that determine if it is a polynomial or not. So again, -3 is not because it's a negative exponent. All right, and then 1/3 is not because it is a fraction exponent. Now, if you had, let's say, x to the second over 3, that's a polynomial because this is really the same thing as 1/3 x squared. So we just want to make sure that you understand that it's the exponent that we're looking at. If the exponent is negative, it's not a polynomial. If the exponent is a fraction, it's not a polynomial. But I can have the number in front of my exponent or my variable with an exponent, and then I'm still good. So a term is a constant, okay, which is just a regular number, a variable, which is one of our letters, or the product of the two. Okay, so these are examples. These would be an example of constants, examples of variables, examples of terms. Okay. So as we're looking, or a term, so 3x is a term. Maybe I should specify it. So a term is 3x, 2y is a term, 20z is a term. This is not, we're not adding or subtracting those, so we're just talking about each one of them individually. Polynomials can have different sizes. So as we look at a polynomial, poly means many, and nomials is our term, so we've got many terms. So if I have a monomial, that means I've got one term. That means I don't have a plus or minus. I have 2x squared or I have 5x. A binomial means that I have two terms. So notice that I have that operation sign. I have x plus 3, which is 1, or I can have, which is two terms, or I can have x cubed minus 2x, two terms, because of that plus, okay, or the minus that separates them. And then if we look at our trinomial, tri means 3. Think of a tricycle. It has 3 wheels, so 3 terms. And so we've got one term, two terms, 3 terms, and notice that they're separated by an add sign. They could be separated by a subtract sign. But look at those, the prefixes, to help you remember which one is which. All right, so that tri again is 3 terms, like a tricycle, and the bi is like a bicycle, okay, which has 2 wheels. So just things to keep, to help you kind of think of which one is which. All right, so a constant is a term without a variable, okay? It's just a number, which we kind of talked about up above. The degree is the largest exponent of a polynomial. So when it talks about the degree of a polynomial, we're just talking about the largest exponent in that polynomial. The standard form means that we're going to write the polynomial from the term with the biggest exponent in descending order until we get to our constant, or our term with the smallest exponent. All right, the coefficient is the number in front of a variable in a term, and then the leading coefficient. And so I want you to kind of think of those two pieces as a little bit different. The coefficient is the number in front. So if I was looking at the monomial, the coefficient would be 2 because it's the number in front, or it would be 5. Those are just the coefficients. If I look up above, my coefficients would be 3 or 2 or 20. The leading coefficient is once I've ordered my numbers from from the biggest exponent to the smallest exponent, like we have in this example right here with the trinomial. Once it's in standard form, the leading coefficient is the number that's in front of the first term. Okay, so the leading coefficient for this polynomial would be 1 because that's the number that's in front. The degree of this polynomial would be 2 because that's the biggest power. The constant is the one without a variable, so the constant is a 3 based off that polynomial. All right, so hopefully that makes sense. Great, so again, here's our 3 terms. So like terms are terms with the same letter to the same power. And those are the ones that we can combine. And we combine the numbers that are in front of it using or taking the sign that's in front. So when I look at example 1 and it talks about putting it in standard form, we're looking for our our largest power. So when I look at example 1, our largest power is the m to the 4th. So I'm going to write that down first. So I've got 5m to the 4th. And I just like to cross it off. And then my next biggest power is the power of 3. And I take this sign that's in front of it, which is a -8. So that sign goes with it. Okay. Then we have 2m. Again, there's no sign in front of it, so it's a positive or a plus. And then our last term is our -6, and so we're just going to write it down. And now when I look at that problem, my degree is the exponent, my largest exponent, which is a degree 4. The leading coefficient is the number that's in front, so it's a 5. And then the constant is the number at the end, which is a -6. If we look at example 2, same idea. I'm looking for my biggest power. So my biggest power is 5. So that's what we're going to write down first. My next biggest power is the 3, and I take the sign that's in front of it just like I did with the 15. So it's a -4 x to the 3rd. My power for 2, or for my next biggest power is 2. So I'm going to take the sign with the 2 out in front. So it's 2x squared. And then I have a constant of 8. So when I look at my degree is my biggest power. So in this case, it's 4. The leading coefficient is the number that's in front, which is -15. And the constant is that number in the back. Okay, so again, degree, leading coefficient, constant. Okay, just like on the other one, degree, leading coefficient, constant. Now with that, once we have, if they ask us to do that, then that's all they're being asked to do. We also can add and subtract. And so I'm going to show you 2 different ways. Horizontal is just you keep it in the horizontal form, and we're just combining like terms. And when it's an addition problem, we're just going to add the numbers that look the same. So we kind of just ignore our parentheses and we find the ones that look the same. So notice that my biggest power when I look at both polynomials is a 3. So I've got 2x to the 3rd plus 4x to the 3rd, which is 6x to the 3rd. Then the next one, my next biggest power is a 2. So I've got 4x squared plus -5x squared. And if you struggle with your integers, use a calculator just to double check. So this is -x squared, -1x squared. If we have -6x plus positive 10x, we get 4x. And then we have positive 2 plus positive 7, which is positive 9. Okay, that would be horizontal. We're just doing it like across horizontally. If I'm doing subtraction horizontally, it's the same thing. What I would do is I'm going to pretend there's a -1 here, and I'm going to distribute that -1 to everything inside. Pretend I put a 1. Okay, so -1. And so I'm going to distribute the -1 to everything. So this is going to be 4x to the 4th plus 10x minus 2x squared plus 5. So nothing has changed with the first polynomial. Second polynomial, I'm going to distribute the -1. So -1 times 7 is -7. -1 times 3x cubed is -3x cubed. And -1 times -7 is positive 7x squared. So what that really does is it just changes everybody's sign on the second polynomial. Once you're there, we're going to combine like terms. So as I'm looking at that, I'm saying, okay, my biggest power is 4. I'm going to write it down. My next biggest power is 3. I'm going to write it down. I didn't have anything for me to combine it with, so I just write it down. Then I've got -2x squared and positive 7x squared. So -2, because I take the sign that's in front, plus 7 is 5. So we have 5x squared. And then we look for our next one, which our next biggest power is just an x. There's only one of them, so I'm just going to write it down. And then the next thing I have is this positive 5 minus 7, which is -2. We didn't talk about this, but I just wouldn't mind just chatting. Remember that this is your constant. The 3 is your degree. And your 6 is your leading coefficient. Okay, same thing. In this case, 4 is your degree. This 4, okay, that 4 is your leading coefficient. And the -2 is your constant. I know like on the other, like for my other class, there was also a question that talked about the leading term. In this case, if you're looking at the leading term, it just means the whole entire first term. So the leading term would be like 6x to the third, okay, the whole entire term, or 4x to the fourth when you're looking at example 2. So just in case you see that. Vertical method. The way we do vertical method is we are going to basically add up and down vertically. And so you're just going to take the values that are in the second polynomial, you're going to line them up with the values in the first polynomial and just see where you're at. So as you're looking, the 3x to the third, notice that the first polynomial is already in standard form. So I'm going to take the second polynomial and write the values underneath. So this is going to be 2x to the third. It's going to go here. The 5x squared is a positive, so positive 5x squared is going to go underneath it. -x, and then -2. And so we're just bringing it over, and we're saying we're going to add these two values together. And so vertical is because they're up and down. So x to the third, 3 plus 2 is 5. Remember, when we combine like terms, our variables just stay the same. Okay, -2 plus 5 is 3. And then remember, these are 1. So positive 1 plus -1 is 0. So the x term goes away. 7 plus -2 is 5. If I talked about the degree is 3. The leading coefficient is 5. The constant is 5. When you do subtraction, it's a little bit trickier because you want to keep track of what's going on. So if I'm doing subtraction, I again like to distribute that -1 to everything. So when I do that, this becomes -4x to the third. This becomes positive 2x to the fourth. And that becomes positive 3x, because I'm taking that -1 and I'm giving it to everything. So now when I rewrite it so that I line everything up, remember that I need to make sure that I line everything that goes with the right spot. So notice, if I'm looking at this one, I have a 5x to the fourth, so I'm going to put a positive 2x to the fourth underneath it. Notice that I don't have a power of 3. So when that happens, sometimes you just want to rewrite it because you've got 5x to the fourth. You kind of have like a 0x to the third, minus 3x to the second plus 2x plus your constant. That's your first one expanded out so that you have each position 4, 3, 2, 1 constant. Because when I take this second value and I go to put it underneath, I have an x to the fourth, which is going to go here. I don't have an x to the third term in my first polynomial, but I do in my second. And so if I'm doing it vertically, I kind of need to hold that place. And then I don't have an x squared term, but I have an x term, which is going to go here. And so now, once you've distributed, now this is an add problem. So 5 plus 2 is 7, x to the fourth. 0 plus negative 4 is negative 4, x to the third. Negative 3 plus really 0, because there's 0 x squared here. That's going to be negative 3x squared. 2 plus 3 is 5x. And there's not a constant, so 10 plus 0 is just 10. Constant is 10, degree is 4, leading coefficient is 7. I don't care which method you choose, whatever is easier for you. Personally, I like horizontal better, but you guys can choose what you like. Same thing with these example 1, example 2. Why don't you try them on your own, pause the video, and then go back and see if you're good. So as we do it, remember that we like to distribute that negative sign. So if I distribute the negative sign or the negative 1, however you're looking at that, you're giving it to every piece. And so this is 9x to the fourth minus 7x to the third minus 10. And then this is going to be minus 2x to the fourth minus 5x to the third plus 2x squared plus 20. Okay, because I go negative 1 times 2, negative 2. Negative 1 times 5, negative 5. Negative 1 times negative 2, positive 2. Negative 1 times negative 20, positive 20. Because really, remember that we are distributing a negative 1. Every time I do that, it makes it look like I'm changing that minus to a plus. Okay, and so once I do that, then I'm going to combine like terms. So I've got biggest power is a 4, so 9 subtract 2, which is 7. I have negative 7 subtract 5, which is negative 12. Notice how your letters just stay the same. I'm not doing anything with it. My next biggest power is that this power of 2, and I don't have another one, so I'm just going to write it down. And then my next biggest power would be an x, which I don't see one. And then so my last thing that I'm going to do is my constant. So negative 10 plus 20 is positive 10. Okay, that would be if you're doing horizontal. If I was doing vertical, we'll do this one vertical. First thing I think would be the easiest is to distribute that negative sign. So we're going to go negative 1 times negative 4, which is positive 4x squared. Negative 1 times 5 is negative 5x to the fourth. And negative 1 times negative 7 is positive 7. So now when we go to rewrite our values, once I've got rid of that negative sign, then we've got this polynomial plus this polynomial. I'm not going to rewrite it. Okay, this is going to go down here. So I'm going to rewrite the first one so I've got all my terms. So my biggest power is a 4. So I've got 5x to the fourth plus 0x to the third plus 4x to the second plus 0x plus 7. And I'm just holding everybody's spot because my biggest power is a 4. And I'm just going to go 4, 3, 2, 1 constant. And now I'm going to take my second polynomial and line everything up. So when I look at my second one, I don't have a power of 4. So I'm going to put the 7 under, or the 7x to the third under the x to the third term. So this is going to be a 7x to the third positive 4x squared. So I'm going to put it the 20x squared underneath the x squared term. I'm going to put the 4x underneath the x term. And I'm going to put the constant under the constant term. And then it's basically 5 plus 0x to the fourth. So it's like holding the spot here, which is 5x to the fourth. 0 plus 7 is 7x to the third. 4 plus 20, 24x to the second. 0 plus negative 4, negative 4x. And 7 plus 15, which is 22. So that is all for the notes. There is like a little in-class assignment that you should be working on to double check that with, we'll just double check that in class. So that's it. Thank you guys.